Eric?
Hello, Mark. Hello
Well,
again.
evening for you.
Well,
Even
almost. It's
what time
actually
is it?
around 5 o'clock.
Oh, okay. So yeah, it's here I would
Evening is
consider that
starting.
evening. I'd say here typically afternoon lasts until about 5 p.m. maybe, and then evening is after that maybe. So
So
culturally.
we are on the border.
In Poland, do people eat dinner early or late?
Wow. It's right now. It's quite hard question. 20 years before, typically it was the lunch was served very early, around 1 p.m. or something like that. Dinner around 6. However, with all those changes, this changed as well.
It's
I'm
funny
eating
that you
very
say
early.
It's funny you say 1 p.m. is early because I think here in Minnesota it's very typical to eat lunch between 11 a.m. and noon.
Oh, okay, really early.
Yeah. And then dinner is any time between maybe 5 p.m. and 7 p.m. is fairly standard. But so it's not so there it's not like in Italy where maybe they have dinner at 8 p.m. or 9 p.m. or something.
Well, personally, I tend to have a dinner very late, around maybe 8 o'clock.
Okay. Is that typical?
Uh, Actually, I don't know. It it's right now it's very fragmented. Uh, people don't Many people don't even eat in home. Uh, they move to restaurants.
Ah,
It's faster and sometimes even cheaper, but
that's
definitely
interesting.
less time consuming.
Yeah, here the restaurants are much more expensive than eating at home. So with two children, going out to a restaurant would be uh, maybe 3 or 4 times more expensive than making the equivalent dinner at home.
Ha,
All right, well, I think we have our crowd, 4 people today, but it's not much going on because Sage has been gone, so I think it's fine. Um, Maybe we get started. So the first new PR on the list, Radek, is your PR that was just this morning for the perf counter work. I think you had mentioned in stand-up that there was some additional things that need to be done.
yes, I need to rebase it to freshest masters. Got a merge conflict recently.
Ah, okay. And from what I recall, previously you had said it's a couple percentage performance
Well,
advantage.
depends on a test, number of clients. I'm seeing values. I'm seeing improvement between 1.5 to 2.5%.
Okay,
Maybe getting close to 3. It depends on the testing.
yeah.
I assume it's around 2%.
Out of curiosity, with your new things, uh, I had just recently used the perf counter framework for some of my stuff and was irritated at having to put in kind of the starting value and ending values and
Yes,
not just yeah
yes,
it was very inconvenient.
it's
Is
killed
your
right
stuff
now. Never
what was
more.
that?
It has the idea has been removed completely. Never more.
Excellent. I like to hear that. It was
The
very inconvenient.
idea right now
Old
is
one.
to have some kind of metadata, a small structure describing a given counter. Its name, its priority, its description, all those things. However, those the counters are described with such structure with instances of such structures of such structure that are made const exp. It means it can be used as a unique identifier when it comes to putting those single perf counters into a graph. Perf counters T, which is
Excellent.
just something very similar to what we have before to the camel cased perf counters class.
Okay. Nice. So more convenient to use and faster. That sounds like a win.
I guess the, the thing that I'm most satisfied with is not the performance, is that all those validations we have, perf counters, have been moved to compile time. So
Okay.
if you are going to misuse a method for increment of a counter that is not compliant with the counter type, then you will compiler will tell you about that.
Excellent.
Compiler, not a run time asset,
Runtime. Yeah.
which was also
Good.
pretty because of additional branches we had.
Sounds good to me.
In the
So
branch
go ahead.
there is a comment showing intended assembly that should come from employing the perf counters in a graph. Let me find.
Once my new thing gets merged and we backport it, then after that I'll try to switch my stuff over to using this.
But please keep in mind there are also some restrictions. You need to know about the metadata of perf counter at compile time. That stays in contrast to what we had before. However, personally, I'm not entirely sure whether we really need to have the feature of declaring new counters dynamically.
I do use that sort of right now. Well, no, is it that the grouping of counters also can't be dynamically declared, or is it like just that you can't? So right now I did change my stuff around a little bit based on what you had said earlier, so that I'm not totally dynamically creating counters, but I do have different groups of counters that get kind of created. Anyway, we can talk about it
That's not.
offline, but
You can have multiple numbers of instance of perf counters graphing. It's not absolutely a problem. All you need to do is to have a knowledge about how a graph of perf counters should look like. You need to do that in compile time. It's because the perf counters group is basically a template over a set of metadata, something like that.
okay. Well, let's maybe we can talk about
But after,
first stand-up.
if you have this knowledge, you can easily create a multiple number of determined at runtime of a given perf counters graph.
Okay. It sounds like maybe it will work, but maybe, let me show you the code. Maybe tomorrow we can.
Sure.
Let's see. Yeah.
Anyway, the new implementation can coexist with the older one. There is a new interface for reading those perf counters. They are compliant from the reader standpoint of view.
Cool. Okay. Sounds good. The only other new PR this week was I finally submitted the PR for my kind of final cache binning work. It's pretty big. It more or less just starts out by cleaning up some things that were left over from implementing a new RocksDB block cache in Ceph, the LRU binned cache. So we moved the priority cache interface to that thing rather than the key value database, which was kind of crazy having it there anyway. And then on top of all of that, we start building in the binned LRU cache, a new priority cache manager that utilizes that, et cetera, et cetera. The good news with it is that it does kind of seemingly what we want, I think. It does a good job of kind of rebalancing caches based on the use case. If there's 4 megabyte sequential writes coming in, it really starts favoring data cache. If there are 4K random writes coming in, you'll see either the metadata cache or the KV cache get the lion's share of the available memory, depending on whether or not you have enough cache to cache all of the metadata in the meta cache. So the behavior looks like it's kind of seemingly what we want. In terms of performance, it's not. Most of the recent tests I've done show it kind of within the margins of error. Sometimes it looks a little faster, sometimes it looks a little slower. It's not dramatic. So it could just be that other things are slowing us down enough that that it's not having a big effect. It could be that maybe none of this really mattered that much, but I kind of doubt that just based on what we've seen in the past. We've seen a lot of cases in the past where changing these KV value or the ratios of cache do have an effect. So I think it's going to be important to dig into it a little bit more. One point is that I've been doing all of the testing with the data cache enabled, and there's a lot of overhead in the mempool thread for trimming the data cache. So it could be that just doing all that trimming in the mempool thread itself is kind of masking anything else. So anyway, there's more investigation to do, but I think the behavior is good. The only question regarding behavior is whether or not we might be imposing some memory allocator overhead by kind of swapping or switching from one kind of cache type to another kind of cache type, and now there's more fragmentation or something because of it. So anyway, that's out there. I'm still running tests on it. We'll see where it goes. Those are the only two new PRs that I saw this week for performance. There's other stuff, but it's been kind of slow. In terms of closed stuff, there's some new lockless auth work that Kifu did. I think Casey reviewed it and thought it looked good. I know Sage was going to look at that too, but I think he's been out this week in Boston or something, so I'm not sure he got a chance to look at it. There's this optimize recover order PR that I think Neha looked at in primary log PG. I don't know how that actually intersects with any of her work. But anyway, she looked at it, and I guess it must have looked good because it got merged. And then Jason merged a kind of librd thing that I haven't looked at all. So yeah, that was it. So now a whole lot new or going on this week, but people are pretty busy. It's kind of the end of the summer, and we've got a conference coming up that a lot of people are going to. So perhaps after that we'll pick up a little bit. I've got a couple of things. We kind of already talked about the bin$u cache. I'm going to try to present a little bit more about how that works uh, and present graphs and that kind of thing at some point, but it's not ready yet. So I'll just skip that for now. Um, over the past week while I've been running tests on that stuff, I started looking at replacing the standard list in buffer list with small vector. Um, it turned out that Radek had already done basically everything I was already doing, and there was an issue with iterator invalidation moving away from standard list, and the way I was trying to solve it was kind of ridiculous compared to what Radek had already done. So I ended up just adopting Radek's code for it, and yeah, everything works fine after that. So when I did that, the results I saw were almost always just a little bit slower than master. Again, it was maybe within the margin of noise, but it was always on the low side of it, whereas master was always on the high side of it. So I think there's probably an effect there. And I think Radek, based on what we had talked about, you were also seeing not consistently higher performance at the very least, right?
Yes, exactly. I was seeing also regressions, and moreover, it was varying with multiple things. Testing in vStar deployed cluster, I was seeing different results in comparison to I had on CBT runs. I speculate it could be because of the very extensive usage of buffer list in Ceph. We eradicated that, so maybe retesting might be a way to go. Not sure.
When you
However,
were doing your vStart tests, were you setting the tcmalloc thread cache to a larger value than default?
on vStart SH, I don't think so.
That could be the other thing, is that CBT by default
Might be.
should be. So yeah, it might be that. I was definitely noticing that tcmalloc, in some of the cases, the buffer list was doing so much creation deletion of objects that that it was making tcmalloc start thrashing a little bit.
What was also funny was that the benchmarks we have for a buffer list showed huge improvement. But in real
Okay,
situations, well, I was seeing also regressions. It's very
that's interesting.
it was very weird behavior. Also, I think that basically the branch I was testing not only switching to a small vector, but also improved inlineability of the buffer list. This
Yeah,
was
I saw
critical
that.
for daemons, for OSD, before we before we switched to linking Ceph common statically, because of necessity to go through PLT. After merging, yep.
Go ahead.
I think that I haven't retested since the early months of this year or something like that. It was half a year ago, something like that. But maybe it's worth to get back to the idea, at least to understand what is causing, what exactly is causing the regression we see. I'm poking a bit with the branch, rebase it to master, stripped all inlining related stuff, leaving just the small vector transition alone. I plan to give it some profiling to the branch. Maybe we'll know more.
So my version of it is just slightly different than yours. I mean, it does. Uh, when we were previously doing in place front, for the zeroing at the beginning of the buffer list. Mine just it does it a little bit differently than yours, and there's a couple of other minor differences, but otherwise, I mean, it's really similar. But I don't do any of the inlining that you did. So there's that difference. I wonder though if even if we see a minor regression with the small vector, I wonder if it maybe puts us in a better position to be able to do things in the future, like stack allocation all the way through for single element buffer lists, if that kind of makes sense.
This it's I don't know, Mark.
Yeah,
What I'm afraid about is that we just don't understand what's going on in buffer list, in the optimization. It can be
yeah.
that there is some hidden use case that it's hurt really bad with the patches. I have
I
no idea.
wonder.
I
We
think we need to deeply understand what's causing the regression.
I think one of the things that I'd like to try doing is instrumenting buffer lists so that we know how many single pointer buffer lists we end up with, and how many buffer lists we end up that have pointers with very small numbers of characters in them.
Sounds reasonable. What can also play a role is the difference in use cases for buffer list employment. At the moment,
Yes.
we are using this bit for almost everything, since encoding through cache of Bluester, ending to our network layer. It's almost everything and covers a lot of I guess very different use cases. Might be also
Yeah.
that we got nice improvement in some use cases, but hurt another one.
Yeah. It looks like I don't think that we actually do like prepends on the buffer lists
I
or
guess that Sage. I saw comments from Sage killing some prepends.
okay, yeah, it could be. It didn't look to me like we do it very often, and I think in some of the other cases that look bad for small vector, right? Where you're shifting memory around or whatever. I don't think we do it horribly regularly. I mean, we should probably look and make sure, but it'd be good to know what our actual usage patterns of buffer list really look like, and if it makes sense to how often everything that we do in it makes sense, I guess.
Yep. Maybe it was not related to prepends. Maybe it was because of copying memory. We put extra bytes to buffer list. So when it comes to making a copy, even a move, there is more things to take care of.
I was wondering too a little bit. I need to go back and look at the profiling results, but even just the creation and deletion of small vector itself, if it's higher overhead potentially than standard list or something. Maybe the constant time overhead is actually enough to make it, look bad.
Might be.
Yeah, who knows?
Yep,
Anyway, I guess. Go ahead.
we have thousands of different users of the buffer list, each with differentiated usage patterns. That's the man. That's the pain.
Yeah. All right. Well, I guess maybe the answer is we need more info. We gotta figure out what's going on. Only
Another
other
topic
thing.
is
Oh, go ahead.
another topic is the memory management pattern you mentioned in mempool, Fred. I also took a look on this guy a bit. And it seems also it's not per se the visitor mempool. It's not so critical. It takes around 10% of CPU. However, it does a lot of risk, costly from the TC-malloc point of view. Costly because of the traffic that needs to go to the central cache. Unfortunately,
Yes.
all this costly traffic is performed under cache shards lock, and that's a potential way how our TP OSD TP threads can be affected because of the less important, I would say, Bister mempool. I
Yeah.
have a patch trying to fight a patch for just for experimenting whether there is any difference or not, whether it's basically not a solution, just a measure to verify whether it's worth digging more in this area or not. I haven't tested the branch yet. I plan to do that as soon as possible.
Okay. Yeah, once you test that, let me know because I might want to try that also with my cache balancing stuff because in all the tests I did with that, I definitely saw the mempool threads spending a lot of time working on trim, just like you saw in your tests.
I don't know. Is the size of buffers constant?
What? Sorry, I don't follow.
The mempool thread is responsible for freeing buffers of the BlueStars cache.
Yes.
And if they are constant, if the length of such buffer is constant, we could try to address the problem with some kind of slapped allocations. If not, well, basically we would mimic we would mimic a memory allocator, full-blown memory allocator.
Maybe I'm not thinking of this correctly, but how could the size be constant?
Because of, well, I don't know.
Okay. I don't think so, but do you mean the overall size or the number of pointers?
Overall size of a single buffer entry.
Okay, I don't think there's well, I don't think there's any way it could be constant, but maybe I'm not thinking about it
I
right.
haven't checked that. I just don't know.
Okay. Yeah, I don't think so, but I would love to be proven wrong. So
No, if that's hard because sure we can move the allocation from the log, but still other users of still the unfriendly memory management pattern will be there. It will be affecting other users of TC-malloc.
Radek, one thing that's been kicking around in the back of my mind a little bit is just reusing as many objects as we possibly can, rather than creating and destroying them.
But this will be very good idea under assumption, but I don't know how it plays with size of those objects, with different size of those objects.
Yes.
If they would be constant, then the problem would be reduced just to slapped allocations. Very easy.
Yes.
We already had a pull request bringing support for that. We could resurrect that. Not a problem at all. But if the size is constant and we want to fight that by introducing a memory allocator, we would end. I am afraid we would end with our own implementation of malloc and free, which isn't a.
Yes, quite possible. Yeah. Ultimately, it comes down to the C string underneath it all, right? I mean, everything else is kind of, you've got some number of pointers, you've got, a couple of other data types in there, but it's all pretty straightforward. It's the variable length, C string underneath it all,
Yep,
or
and that's
number
the
of them,
problem.
yeah, the any number of variable length C strings underneath it. So, yeah,
Maybe
but
we could
but
try
still,
to.
you could still stack allocate all of the other stuff, right? And just be left with the C strings.
Hmm.
And then maybe you could play games where for short ones you could allocate it on the stack, just like, small vector does, but I don't know.
Maybe we could froze. Maybe we could introduce some predefined sizes of buffers and just sacrifice memory for the sake of less TC-malloc traffic.
Yeah. I think
But
we need
I,
statistics though to find out how often that really happens.
yeah, for RBD, I guess typical operation size is a power of 2. But I'm not entirely sure about RGW.
Yeah. I do wonder though if we could get away if we could basically stack allocate a lot of the non-variable length stuff. I wonder if that could help TC malloc enough that it's no longer it's only dealing
Okay,
with the variable as strength, so it's not worrying about all this other junk,
I see.
right?
So you want to make some more room, more space just for the critical, for the essential dynamic allocations.
Yeah, I wonder how much like all of this other junk is polluting TC malloc's space. I'm trying to remember how TC malloc works compared to JE malloc. But JE malloc tries to like create like groupings of like-sized objects together in memory, if I remember right. Um, and I wonder with TC malloc if it does something kind of similar or not. I forget. But anyway, I wonder. I've got to think that the more of that kind of stuff you remove from TC malloc, so it's really just focusing on like dynamically allocated things. I wonder if
However,
you get those things out of the way, if it helps, if it can, I don't think it could hurt anyway.
guys, do we need to deal with that at all? Maybe in a long perspective, C-star is the answer.
Probably
If we
true.
would able to take care of all of our activity in a sharded way, then the very nasty pattern that mess with this TC malloc should go away.
That's probably true. And then the question is, how soon are we gonna get C star? Do we need to fix anything else before that, or can we just like punt on all of this and let the
Too
because it's
soon,
always
I
going to be
am
different there,
afraid.
right? Yeah, I know, but it could be years, right?
Yes,
So
I am afraid, Mark, it will be a very long story.
yeah. Next week, Casey said that he and Adam and maybe Matt can come, and I don't know if it will. I guess maybe not next week because everyone's going to be at Mountain Point, but at some point soon in the future, he said that they could come and talk about what they did with the C star buffer implementation because they somehow they've got something there that they've wrapped where it's compatible or works with our encode and decode existing encode decode stuff. So potentially maybe that's a segue into that conversation of what does the C star world look like? How are we using it with our encode decode code, and maybe that will help us and help inform us on what we potentially could do with the existing OSD.
Hopefully.
All right. The only other thing I was gonna say is I'm starting to work on better result parsing code for CBT, or actually making something real rather than a bunch of awk scripts that do it. So hopefully that will be here soonish. I don't know. Anything else, guys, for this week, or should we wrap this up?
Almost forgotten. I was debugging. I was profiling the debug MS further, and it turned there is another third source of the messages performed under a lock. What is funny? It's in async process, async connection process. I have a gist. Let me find. Okay, got it.
Let's see.
And what is very important is that the last debug, the one in async connection process, is not on the first level. It's on fifth. I was wrong. It's on fifth.
Sorry, Radek. What were you just saying?
1 week ago, I was thinking we have only two debugs. I mean on the hot path.
Oh.
Yep, and all of them are put on the first level of
Yes, I see.
gathering. I was wrong. We have three. Actually, on read path we have three such debugs, and the last one is on fifth level.
I see.
More importantly,
that's not default though, so that wouldn't matter,
default
right?
is 0/5.
Oh, I see. Okay,
Yeah.
I thought it was 0/1.
Unfortunately, no.
Okay.
More importantly, the RX debug is crafted under connection lock. So if you have a client with long, basically clients issuing requests with long IOQ are hurt the most, I guess.
I wonder if we actually, well, I don't know. I was gonna say that I wonder if the default should be 0/1, but maybe this is actually important.
Yep, it's a long story, most related to not technical cases per se, but rather to our protocol with to our interface with cluster operators.
Yeah.
Anyway, I guess we will need to get back to that, because those three debugs are worth 70%.
Oh wow. So those three things are 70% of the
Yes.
usage of the debug?
Nope. Killing those three debugs gives you 70% more IOPS.
70% more IOPS?
70 more IOPS. Let me.
Oh my gosh. Wow.
I have a gist. Let
Oh,
me find and
uh, what if you kill everything? How much more do you get?
here it is.
So if you kill everything, how much more do you get?
Uh, with killing those three, the bugs I've got. Uh, 1 second. PT and insert a 07 performance comparison. Okay, the numbers are there. 267 versus 401. I mean debug ms equal to 0/0.
Okay, so if hey, by the way, the race in make part NVMe NVMe BS, I don't understand why parted has a race because I've seen that too.
Fun?
Sorry, what was that?
You were talking about arrays.
Yes, yes, yes. Remember in when you run parted, so make part NVMe NVMe BS, your fifth run failed to spawn because of a race, right?
Ah, yep. Yep,
Yes,
yep, yep, yep. I'm having such problem from time to time,
me
and
too.
it's Jesus, it's painful because the run is pretty long. So if you face the problem, you need to start from the beginning.
Mm-hmm.
I
Yeah,
was
it's incredibly irritating.
yep, I was trying to fight the problem with ensuring there is no more processes having open files on the file system we are going to unmount. I put kill all in a loop, uh, ensuring we are calling the MK part with without unusers. But may I have a I was
Did it
I was
did it
sending a
fix it?
signal just to CephOSD, Cephmon, MGR, but maybe there's something different, something more. Maybe we should use lsoff to verify to verify whether there is no process with open file on a file system we are going to unmount.
What I don't understand is why, after parted has completed, why is it that we can end up in this situation? How is it that parted is not like ensuring that everything is synced before it returns? Because that's what it seemed like to me, is that was an issue with parted rather than anything else. But maybe I'm wrong.
Mark, I have no idea.
Okay.
I thought about that a bit differently. I was assuming that the script cannot do its job uh, because because there is another process that has a file, at least one file, open the file system that needs to be cleaned up before calling part.
Could be. Maybe that's it. But I swear I've seen it where I haven't even I have a file system open. Like I've closed it long ago. There's nothing open. But if I run multiple iterations of parted over and over again, I can hit it. I think so. It's been a
Wow.
long time since I looked. But but I'm not sure it's the file system. It might be, but I don't remember. I haven't looked at it in like a year or two.
Well, nailing down this issue will be really, really, really cool, I think.
I also seem to remember that it didn't happen years ago with the kernels and that it was introduced sometime. So, but I don't
Even
remember.
more complexity.
Yeah, I don't know. It's one of those things that is irritating, but I have never taken the time to actually bother trying to fix. If you fix it, let me know because that would be huge.
I will definitely make a pull request and let you know.
Okay, sounds good. But here, your results. So it looks like to me like okay, you go from 267,000 IOPS. Is that sorry?
There is
These
a
IOPS?
sandwich in kilobytes.
Oh, kilobytes. Okay, so 267 kilobytes to 345 if it's with those removed. The two, but not three, right? Is it all three of the things that you identified, or just two of the things you identified?
Yes, just two of them. That's the last part shows the cost of the RX debug. It's performed under a
I
lock,
see.
so I guess that's the reason.
I see. I see. Okay, so but just moving those two gets you most of the way there. Well, sort of. It gets you
Yes,
like
but
two-thirds of the way there.
I haven't posted that. I can recall that after pacifying, after bumping the level of the RX debug, I was seeing numbers almost entirely close, almost the same numbers like in case of having debug set entirely to 0.
Ah, very good. Very good. So really it is just those three that are hurting us the most.
Yep.
Okay, cool. Well, I think then you've got your answer, right? What we need to figure out how to fix.
Fixed in a way that that won't surprise operators. That's the tricky part.
Yes. Mm.
But Sage already or has already sent an email to Ceph Devel asking about a real usage pattern of those debugs, and basically from my understanding, people could live without the default we currently have.
Sure. I
And many
wonder
of
how
them
much.
were
Oh, go ahead.
and many of them were surprised that setting the debug MS might bring such results, improvement.
Yes, I honestly didn't realize it was so concentrated. I knew setting debug to 0, 0 helped significantly, but I didn't realize that the majority of it was just debug MS.
Yep, I was seeing those long list of debug setting in reference configuration, both in case of Intel, but in case of Samsung, all in everything set to 0 in their reference testing.
Yeah, and I think they got that from me because I started doing that in CBT a long time ago, and I think other people started picking it up. Because otherwise, the debug would just mask other problems, and you couldn't actually test anything. If
Well,
you know, if debug was slowing everything down, then 3% improvement from some other PR is totally lost.
but this assumes you have enough enough space of in terms of course, in terms of CPU power to see the difference. I mean,
Yeah, that's true.
it assumes that the messenger is bottlenecked, while TP OSD TP could consume more, have a room to consume more computational power.
Yeah, yeah, very true. Um,
I'm
do
afraid
you
that in
think?
typical situation,
I was just going to ask, do you think that if we had a binary log format, even just for some things, that we could dump this data into that quickly?
We will definitely, yes, I think so. We will definitely remove the overhead coming from get name info. It's the dominant guy for each of these debugs. Second one is MOSD print. Pacifying this thing is slightly more costly, I'm afraid. The question is how much, because we would have basically a trade-off. We would just copy more to avoid some processing of logs. But still,
yeah.
I'm still afraid that we are putting a lot of complexity just for the bugs.
Yeah.
To be honest, I would really love to go with the absolutely simplest, the very, very dumb solution, which is just moving the stuff from the hot path, moving them out. And maybe we wouldn't need to. Maybe we don't need to mess with the debug MS at all. Maybe just bumping these levels of these three debugs is a way to go, because most of I've got a feeling they are just something like info level, not something that is absolutely critical, not something that signalizes a problem, issue, something weird. No, those are common messages, info messages, I would say.
Yeah. And in the long run, we are going to change all of this anyway for C star. So maybe you're right. Maybe the best solution right now is just to get them out of the hot path, and then we if there are problems, people enable it.
I guess that we already discussed that. If I recall correctly, the most important thing was just to not confuse, to not surprise operators. And we are going to have other changes in Messenger that require some attention from operator, like reading stuff about a new config option. Maybe we could reuse that opportunity to also signalize that we changed something in our logs, in our log priorities.
Yes, that seems very reasonable.
I guess this would be just the simplest way we have.
Yeah.
Without any other complexity.
Yeah.
I also have, if that's not enough, if that's not a way to go, I also have a patch introducing a caching to entity ADDRT, and to be honest, I don't like that patch. I would really prefer to throw it through window.
I think you've convinced me that just get them out of the hot path, and then, if it turns out that was the wrong decision, we can always put them back in. It's not the end of the world. If there are problems on someone's cluster, they can always try to restart with those settings changed. So I think you're right. I think get them out of the hot path. I think that's the right way to go.
Yes, basically, that's good. That's good point. That that change wouldn't be so dramatical.
Yeah. All right. Well, I think we were almost run out of time here, and I want to try to get back to working on some of the stuff I've got to do. So, it was good talking to you, Radek.
The same for you. The same with you, Mark.
All right. Sounds good. Have a good week.
Same for you. See you tomorrow, I guess.
Yeah. See you tomorrow. Bye-bye.
See you tomorrow.